Hi, hello everybody. So this is the video dealing with section 2, linear and compound inequalities, and this is the second part specifically dealing with compound inequalities. Now, in the first section, we saw the basic linear inequalities, which were inequalities of maybe this form, right? Where they look like an equation, but the symbol is either the less than, greater than, less than or equal, greater than or equal. And then we said that, in order to solve these inequalities, we have to, at the end, graph them and write the solution in interval notation. So we've covered that point, and we highlighted the very important fact that whenever we multiply or divide an inequality by a negative number, the inequality will shift direction. Now, compound inequalities are very similar, but they're actually two inequalities or two problems in one. And they're just two inequalities connected by the word and or the word or. And we'll see how to handle each case, but the and case, it's like a intersection or multiplication, and I'll tell you what that is. And the or is more like an addition. All right. And we'll see how to handle that. But to solve a compound inequality, we're going to do these or take or follow these steps. First, we're going to solve each inequality separately. There's always going to be two for you to see. We're going to graph each one on their respective number lines on top of each other. And then we're going to express the final solution in interval notation based on either the case and or. Okay? We'll begin with the OR case because the OR is simpler than the AND case. All right, so let's take a look at this case right here. Okay, this is in your workbook, problem 213, but there are other ones. You can try the other ones as well, but I'm only going to try here two, one of each case, one of OR, and two for AND in order to keep the video not too long. All right, so here is a compound inequality. And how do I know it's a compound inequality? Because I see two inequalities and they're connected by the word or. So the process is we're going to solve each one separately. So here's the first one, and we solve it as if we were solving an equation, right? So isolate the variable, so plus 2 on both sides. Cancel. 5x less than negative 15. Divide both sides by 5, right? The 5 cancels here. I am left with an x. And negative 15 divided by 5, negative 3. Now, in this case, does the inequality change? No, it does not change because I divided or we divided by a positive number. So this is my final answer for that inequality. Now let's do the other one. This is the other inequality, and I am going to solve it by moving the variable to the left side, okay? Because I think it's easier for you, minus 4x here, and if you do it here, you do it there also. So here they cancel. I'm left with negative 4x plus 1 less than or equal to 1. Isolate the variable means I have to get rid of this negative 1 right here. So I subtract 1. They cancel. And I have 1 minus 1, 0. Now I have to get rid of this negative 4 that is multiplying my x. So I have to divide both sides by negative 4. They cancel here. I get 0 there still. Now don't confuse 0 divided by negative 4 is 0. But negative 4 divided by 0 does not exist, right? This is not possible. So don't confuse those. Because I've divided by a negative number, this inequality is going to change sides. And I can see that if I solve this a different way. Let's solve this with the variable on the right. So if I don't move the variable from here, now I have to isolate the variable. So I do minus 1 on both sides. And now I divide everything by 4. And the 4 cancels. Now notice that this is the same as that. Now, how is that? Because we have to read from the variable to the number. So this means x greater than or equal to 0. And here, down here, I would read x greater than or equal to 0. So don't confuse, okay? We always read from the variable to the number. So both ways, if you solve it both ways, you got the same answer, it's correct. But I'm always going to be solving with the variable on the left so that it makes standard for everybody to understand. Now, I got the two answers. I'm going to graph them on the number line on top of each other. So here's 0. Now, in the first case, I'm going to plot -3, so it's here somewhere, and I'm going to shade it into the direction of the inequality, which is going to the left, less than. So here's the shade. I don't have an equal sign, so I am going to use the parentheses. And for the other case, for the other inequality, I am going to plot 0. So right here. And I'm going to shade it into the direction of the inequality, which is greater than. But because of the equal sign, I am going to put a bracket. All right, so that's the second one. Now, because they are connected by the word or means we add the two solutions. It's either one or the other. So you're going to write this interval, -infinity, -3, and you're going to write the other interval, bracket 0, infinity, and you can connect them with the comma. This is fine, I'll accept that. Or in many books, you might see the union symbol. Okay, you can do that. So either case, it's fine. So for the compound inequality with an or, you just add the two solutions the way I did here. So interval for one, interval for the other. All right, let's take a look at the end case. The end case is almost identical with one variation at the end. Okay, so let's see. So again, we see a compound inequality because I see two inequalities and the connector is an end. So I'm going to solve each one separately. Right, -1 on both sides as before. Cancel, -3x greater than 6 or equal to 6. Now I have to divide by a -3. And you already know, because I'm dividing by a -3, the inequality is going to change sides. So 6 divided by -3 is my -2. So this is one solution, right? Keep in mind, the inequality flipped because we're dividing by a negative. Let's solve the second inequality separately. Same as before, right? Subtract 3, 10, divide everything by 2. And because we're dividing by 2, the inequality does not change. Doesn't change because we are dividing by a positive number. So I got the two solutions. I'm going to graph them on the number line, each on top of the other. It's very important that they be on top of the other. I am going to plot the -2. I'm going to graph it in the direction of the inequality, okay, which is to the left. I am now doing this one. I am going to plot the -5, the +5, which is here somewhere. And I'm going to shade it in the direction of the inequality, which is again to the left. So all of this segment is graphed. Now, keep in mind, for the first case, right, because I have an equal sign, we use square bracket. And for this case, we use parentheses. Now, this is an AND case. So the AND case, the solution must be true for this and the second. So you're going to look at the regions where you have a solution in both lines. So take a look at these three segments. I have a segment here, I have a segment here, and I have a segment here. In this segment, on the right side, there's no solution there, so that's out. In the middle segment, there's a solution here and here, but there's nothing there. So this is also out. They are out. The only place where I have solution in both is this segment right here. So this is the AND case. So for the AND case, the solution must exist for both segments. And then you are going to write the final solution, which is negative infinity, comma, -2 bracket, right? Because of the equal sign right here. Okay, so for the AND case, the solution must exist for both in the same region. All right, let's see another case, which is a variation of the AND. It's still an AND case, but it looks differently. Okay, so here's the case. This is what we called a double inequality, but this is an AND case, okay? Now, the correct way to do this is to separate the two. So this is the first inequality. So I want you to write it this way. And this is the second inequality. So this is how we separate them from this double format. So in our course, I don't think I'm going to give you a question involving this double inequality because I want it to be explicitly clear that we're using an AND. So in case you see this somewhere in a textbook, you can always break it the way I'm breaking here. And then you can solve it the way we did it before. So let's solve each inequality separately. And in here, I am going to move the variable to the left side. And I'm going to move the number to the right side, right? Just as we did with linear equations. 5 minus 1, 4. And now notice we're dividing by a negative, which means the inequality is going to flip sides, right? Less than is going to become greater than. So this is 1. Let's solve the next one. So isolate the variable, right? Get rid of the number 1. Divide by 2. Now we're dividing by a positive number, so the inequality does not change, right? Did not change because I am dividing by a positive number. So I have the two answers right here. Again, I am going to graph them on the number line next to each other. So let's do the -2 first. So plot the -2, which is here somewhere, greater than. So I'm going to shade it to the right. And because there is no equal sign, parentheses, right? Greater than -2. Now let's do this one. I am going to plot the +1, which is here somewhere, and I'm going to shade it in the direction of the inequality, which is less than, which is to the left from here. And because of the equal sign, there is a bracket here. So going that way. Now remember, this is AND. So for the AND, I have to find the solution that exists in the same segment for both. So I'm going to divide this segment into 3 parts for you to see, if you can see these 3 parts. Here, here. So I have one segment here, one segment there, and one segment there. Notice that on the far left segment, there's no solution here, but there was one here. But because of the word and, this is out because and means it has to be true for both. So this is out. On the far right, I have the same situation. There's a solution here, but there's no solution there. So that's out. Notice that the only regions where there is a solution for both is in the middle here. Okay? So this is our solution for the AND case. Now it begins at the -2 with the parentheses, comma, and it stops at 1 with a bracket. All right? So in the event you have this double inequality, one right here with these three segments, you're going to rewrite them as the traditional and splitting this first and then that next. Solve them as if they were regular and compound inequalities. Okay, so this is how you solve compound inequalities, compound linear inequalities, either with the or with the AND case.